Hello everybody, welcome. Kevin Dennis with Gravitech Systems Incorporated. Welcome to our training center. Today's topic is on anchorages and anchorage connectors. If you've been with us the last couple of weeks, welcome back. If this is your first time clicking through, every Thursday at this time we are going to have a short 15-20 minute education session on some fall protection, rope access, or rescue topic. So welcome back. We are live streaming. So if you are having audio trouble or refresh trouble, please check your speakers. We've confirmed that audio was working, our feed is working. Please update your audio, update your speakers, and we'll go from there. And if you have any problems, just reach out to me and we're happy to give you a recording of the session. So let's get to it. All right. So like I said, today's topic is anchorages and anchorage connectors. So here I'm in an active fall protection system. It's a travel restraint system. It's clearly, obviously fictitious here in our training center. But every active fall protection system has, three basic components. There's a body holding device. There's a connecting means that connects the person to the anchor. Then there's the anchorage. And this is the part we're going to talk about and discuss today. So the anchorage goes by several different names: anchor system, anchor subsystem, tie-off, safety, anchorage, anchorage point. People use all kinds of different terms to describe this element, if you will. So I'm going to try to boil it down into its most basic format. First of all, anytime you're using an active system, whether it's restraint or arrest, there has to be an anchorage. There has to be something to connect to, okay? And every anchorage has two basic elements. Number one, it's the anchorage, and the anchorage is defined as the structure or the element that's ultimately going to be holding the load and transferring that load, into the earth. 99% of the time, the anchorage is part of a building. It's a column, it's a beam, it's red steel, it's concrete. Maybe it's the frame of a stairwell or a frame of a vehicle or anything, but it's usually, its first intended purpose wasn't for a fall protection system, okay? The fall protection system is being added to that anchorage, typically in hindsight, okay? So the anchorage we all define as the structure. Then there has to be the anchorage connector. And the anchorage connector is basically the widget or the piece of equipment that is used to interact with the anchorage. So in this situation, my anchorage is this column. My anchorage connector is this little weld-on D-ring. If I was connecting into concrete, I would need an anchorage connector that'd be compatible with concrete. So, continuing on with this line of thinking, there's these two parts. The anchorage is the beam, and the anchorage connector is whatever widget you're going to use to connect to it. One of the most common anchorage connectors are tie-off adapters, cross-arm straps, anchor slings, whatever people call it. That goes around the anchorage connector into my system. Here's another example. Anchorage again is the beam. Since it's an I-beam and it has these flanges, I'm able to compatibly connect to that by using the sliding beam clamp, and that slides around. This lanyard I have is actually a tie-back variation. I can wrap it around, so the end of my lanyard now becomes the anchorage connector. I'm not going to spend a whole lot of time this afternoon on the anchorage connector, okay? Generally speaking, you don't have to pay a whole lot of attention to the anchorage connector, at least in regards to quality, because a manufacturer designs it, specifies the material, they test it. You know, generally speaking, everything's 5,000 pounds. They label it, they supply the instructions. If you have a problem with an anchorage connector, chances are you just have a purchasing problem. So you can go out and find, you know, whatever type of anchorage connector is going to be compatible with your anchorage. The part that causes employers the most difficulty is the anchorage, the actual structure. What can be used, what can't be used, how strong does it have to be, is it acceptable for use? You know, the questions go on and on and on. So, the anchorage, let's talk about the strength. OSHA requirements, you have two choices when it comes to the strength of the anchorage. Number one, OSHA, as well as state programs, Army Corps of Engineers, Department of Navy, everybody kind of follows the same requirements for strength of anchors. Number one, anchor has to be 5,000 pounds per employee attached, so that's choice number one. Or it has to maintain a safety factor of 2 to 1 according to the maximum arresting force. And if you're using the 2 to 1 option, it has to be designed, installed, and used under the supervision of a qualified person. So you have two choices when it comes to the strength of an anchor, okay? 5,000 pounds or 2 to 1 factor safety. Everybody agrees with those numbers, okay? We all understand an anchor has to be strong enough to withstand the loads. It has to have some margin of safety associated with it. If it's a permanent anchor, it has to have enough strength to have some life expectancy to that anchor. So nobody argues with the 5,000 pounds or the 2 to 1 factor safety. The challenge is how do I quantify that number? Okay. OSHA says, again, anchors have to be 5,000 pounds. The very next question that everybody has is, how do I know that that anchor is rated to 5,000 pounds? And this is typically where the difficulty comes in. So there's two categories, if you will, of anchors. There's what I like to call proven and unproven anchors, all right? And the crux of it all is if an employer has to quantify the anchor, if they actually have to prove the strength of that anchor, or if they want to prove the strength of that anchor, they only have two choices, and that's through engineering practices or physical testing. Everything else is a guess, okay? So myself looking at that column, I go, boy, it's holding up the building, it's part of my test stand, it's very, very big. I trust it to be 5,000 pounds. Good judgment or not, it's still a guess. The only way for me to determine the strength of that column is to get an engineer, get my steel workbook out, they figure out what's the existing load on it, is it in compression or tension, and how much residual strength does that column have, and will it support, you know, fall arrest or travel restraint loads. That's the only way through engineering. And then secondly, is through testing. Is I grab a come-along and a load cell, and I pull it to whatever quantifying number that I need to have, okay? So any anchor that has been proven through engineering or testing is commonly referred to as an engineered anchor. Everything else that doesn't have legitimate, you know, evidence to its strength is a non-engineered anchor. And that's what is kind of the crux of the problem for employers is, do I have to have engineered anchors? Do I not have to have engineered anchors? I can't have engineered anchors. So that's what I want to kind of summarize the session on today, is to leave you with what Gravitech calls the hierarchy of anchors. Just like we have a hierarchy of fall protection controls, we have a hierarchy of anchors, from the most desired anchor to the least desired anchor. And I'm going to show that to you over at our roof section. So let's move over there. Okay. So OSHA doesn't have any laws that tell employers that they have to have engineered anchors, that you have to prove the strength of every single anchor, okay? That's one of the first misconceptions that everybody believes they have to prove the strength of every single anchor. Gravitech with systems would tell you that that's what you should strive to do, but we recognize that it's not always possible to have an engineer on every job, you know, and qualify every single anchor that's out there, okay? So we've developed this hierarchy of fall protection anchors from the most preferred to the least preferred, and I want to kind of summarize those here. So the best anchor that you can supply for yourself or for your workforce is, number one, is an anchor that's designed, installed under the supervision of a professional engineer, okay? So if you take a look up into the superstructure here of our training center, anything that you see is green is an engineered anchor point, okay? We have them over top of our connex, we have them top of our rope access area, and they're littered throughout the training center. Every one of those anchors, I have a stamp drawing, I have a file with the calculations, I have a user's guide that dictates the inspection requirements, and I have a list of how many people can be connected to that anchor and what equipment can or cannot be used, okay? That's a perfect world. Okay? And I would tell you every single anchor should be hopefully part of a system. Whether it's a user-selected anchor, a pseudo-engineered anchor, any type of anchor, hopefully whoever's involved in that process also identifies number of people, clearance requirements, inspection requirements, who can and cannot be connected to it, et cetera, et cetera, et cetera. Okay? All right. But I want to take a moment and talk about the use of a professional engineer. There's always significant discussions in the fall protection industry of who is a qualified person and who isn't. Can a person who isn't a professional engineer qualify an anchor point? My Hilti concrete rep is, has got an engineering degree, but he sells me the concrete products, and he knows more than anything about concrete. Can he design my anchors? And I try to tell people it with a little different twist, okay? Is rather than talking about fall protection anchors, I ask the person, I go, should you be practicing engineering if you're not an engineer? Okay? There's good reason that the federal government and states require engineers to be professional engineers licensed within the state. You don't want people drilling holes in columns, attaching horizontal lifeline anchors to beams, welding on structural members of buildings that they shouldn't. Okay? So it's not so much that another group of people can't engineer anchors. Like the math is pretty simple, the data is there. It's that many times you're going to be competing against requirements of the state that you're practicing engineering. So in a perfect world, if you are under the jurisdiction of a state plan, you want to have engineers conduct engineering, and it really gets difficult once you start touching buildings, okay? So that's the number one preferred method, and it's what Gravitech Systems always promotes to people when they start talking about who should I have design anchors and how should I do it, okay? We're also realists. We recognize that not everybody has the legal requirement to use a professional engineer. You might be not under the jurisdiction of the state. So the next best anchor is designing, installing, and using one under the supervision of a qualified person. And a qualified person 99% of the time is still an engineer, they just might not be a professionally licensed one, okay? So these two anchors, you wouldn't really see any difference between them other than the certification process of the person who's designing it. Both of them are vetted for strength, both of them are vetted for compatibility, they're vetted for location, and ideally they're supported with documentation of drawings, user's guide inspection requirements, and strength requirements, okay? So those are ideal. But like I said, we recognize not everybody can get permanent anchors everywhere, okay? A lot of times you don't own the buildings that you're working on. Neither of these anchors are very fast, okay? And neither of them are very cheap, okay? It costs quite a bit of money, okay, to dedicate a person and a few engineering hours and product and installation, drawings and certification to it. So you're not going to get an engineered anchor for less than a few $1,000s. So many times the value even if a company wanted to, the value isn't there for engineering. If you don't own the building, you might not be allowed to put in an engineered anchor. And also, many jobs at height are one-off jobs. Somebody's going to a location to do a 15-minute job, and they are not going to return to that location for the next 15 years. It does not make financial or practical sense to not do that work and expose your qualified person engineers to the same fall hazard as the worker while they're designing and engineering an anchor point. Okay? So we understand that these two aren't always possible. So the next category of what I just personally call pseudo-engineered anchors. And these are anchors that don't have the same vetting process by a qualified person or a professional engineer, but they get pretty close. Okay? The best example of a pseudo-engineered anchor are all these roof anchors. Okay? Everybody's familiar with these. They nail down onto the residential roof. Actually, not even residential. Anything that's got a peak similar to a house. And they just nail down or lag screw according to the building materials. Here at our training center, we've got 15, 20 of them back here on our roof section. So the anchorage connector is this part, the actual D-ring and plate. The anchorage is going to be the sheeting, truss, framing, wall forms, foundation of the house. Okay, so essentially you're connecting the entire house. And I call them pseudo-engineered because everybody's comfortable with this part, the anchorage connector. Okay? But the manufacturer has gone one step further, and they've done testing on different substrates and provided you with installation instructions to get the strength out of it. So if you open their instructions for any of these roof anchors, usually there's a bag of a bunch of nails or lag screws, and they will have a listing of all the different substrates that you can connect to and which screws or lag screws and which pattern you have to use to get either 3,600 or 5,000 pound strengths out of these. So that's pretty good. Okay? Like I say, we fall a little short because I don't have a specific drawing. I might not have a stamp, you know, or calculations for each of them, but I can feel pretty good, you know, as long as I install this according to the manufacturer's instructions, because they've done a lot of that testing for us, or that qualification. Okay? And there's dozens and dozens of these pseudo-engineered anchors. Another couple common examples are these roof anchors or constant force posts. I got two examples here. This one is MSA Latchways, and this is a Miller product. But all the major manufacturers have these, okay? So, and what they do is there's a plate, and there's predetermined holes in each of these. And when you open up the user instructions, they'll tell you which holes and which connecting methods to use according to the substrates. So these anchors you can get to attach to wood, concrete. You can weld them to steel plates, or you can even attach them to metal roofs. You know, this particular one has got these clamped down feet, 4 of them. So for standing seam or rolled metal roofs, these clamps, these pinchers, if you will, clamp down to the top of that rolled metal seam. And as long as I install it correctly, I adjust it correctly, I tighten the nuts down to the right torque spec, the manufacturer ensures, because they've done that testing, that it's going to hold to the required strength specified. So those are pretty cool. You know, here's another example. This is a concrete insert. So when I'm doing a pour, I can insert this sleeve into the wet concrete. And now after it's set, I have this large détente pin that hooks into that hole and gives me the required strength. I believe this is a 5,000 pound anchor. We have concerns with the size of the connection, but that's a different topic for a different Thursday. So as long as I get the minimum embedment into the concrete according to what the manufacturer specified, and there'll also be a spec for, you know, 2,500 or 3,000 PSI concrete. I don't know, I'm making this up, you know, or the numbers up as I go along. But the idea is that there's a installation spec to get the required strength out of this anchor. So again, falls short of certification, but you get quite a bit of confidence when you use and install these correctly. And there's dozens and dozens of these pseudo-engineered anchors, okay? So if you don't have the ability, you know, for permanent engineered anchors through a qualified person or a PE, you know, these pseudo-engineered anchors give you quite a bit of confidence in your program. All right, the last type of anchor, or the least desirable type of anchor, is what we'll consider user-selected anchors. And that's where the person is allowed to select their own anchorages according to their own judgment. They don't have any manufacturer testing behind it. There isn't a qualified person or a professional engineer assisting with any kind of vetting process. The worker themselves are looking at structure and connecting to it based on trust, okay? The most common example of that is somebody's got a lanyard on and they've got a lanyard with large hooks. They're climbing scaffolding, tower structure, or whatever, and they use the large hook to connect into the structure. Or the worker themselves, you know, wraps an anchor strap around structure they believe to be strong enough. The anchorage connector is good. We know it's got 5,000 pounds of strength. The concern is the selection process of the user, okay? So, all of these anchors are legal, okay? An employer is allowed to use any manner of these, okay? Over time, and what we would tell you is that as the safety industry grows, as we unfortunately see more accidents and fatalities, we're going to see more and more regulators starting to require, you know, certified or engineered anchors. Currently, Subpart D requires engineered anchors, you know, on the rooftops of building, anything that's going to be connected to a rope descent system. The IWCA, now defunct window cleaning standard, you're starting to see them be included in architectural drawings as buildings are being built. So the whole world is kind of trending toward engineered anchors, recognizing we're not there yet. This is pretty good to have pseudo-engineered anchors, and it's still acceptable to have a trained individual selecting their own anchors. Everybody will tell you that your risk and opportunity for error is higher with user-selected anchors and not as high with pseudo-engineered anchors, although we might be still worried about the installation. And the margin for error on qualified person and PE anchors should be pretty low. Okay. One of the common questions we get is, how do I know that my worker out in the field, if they're selecting their own anchor, whether they're compliant or not? In the appendices to Subpart M, there's a couple of paragraphs where OSHA talks about makeshift anchors. And I'm paraphrasing, but it says something to the effect of, the agency recognizes that there will be a need to devise an anchor point from existing structure. So they're talking about, hey, we know that you can't do this all the time, and there's a need to connect to existing structure. They say that users can use these makeshift anchorages, providing they're trained and have a focus on the proper strength. So there is some tolerance, you know, for user-selected anchors, but as part of your fall protection program, Gravitech Systems would encourage you for areas of high frequency, known work. If you're going to a spot that's predictable, it's repeatable, it's got some life to it, that building's going to be there for the next several years, should invest in some permanent anchors put in by a professional engineer or a qualified person. So, thank you very much. Hopefully that kind of lays the foundation for anchorages, anchorage connectors, and some of the requirements for them. If you have any questions, feel free to email me at dennis@gravitech.com, or sorry, dennis@gravitech.com, or call our 1-800 number and ask for me directly. I think we're putting up my phone number here on the live stream right now, 360-626-1123. And like I said, just reach out to me. We can post this recording. We'll get you the links if you want to use them for toolbox talks or any other type of educational promotions. And next week, we're going to deal with energy absorbers, which will be pretty cool because we're going to break some stuff.